Hey everybody. Well, today I wanted to show you some changes that I made to this rack and pinion lifter behind me. I introduced some safety measures that I haven't had in place before. I've been building lifters for a while, and during that time I haven't had any really bad accidents or any failures of components that would cause harm to me or to the equipment that I've used or to the lifter itself. But I knew that would happen, that it would happen sooner or later. Things like that happen, and mechanical failures happen so quick that it's almost impossible to get out of the way of them or to anticipate them whenever they're about to happen. So I started looking over the internet to see what had been designed in the past by people who had built carriages that went up and down, and namely that was an elevator. So haven't invented anything new, but I've taken some of the ideas that I've seen while looking over what people have done to add safety to elevator operation and applied it to the lifter. It seems like that they go hand in hand. So elevator safety and lifter safety have a lot of components that could be merged together to allow one to operate a lifter with a lot more safety measures applied to it. And one of the things I came across, one item, was an invention by a gentleman called Mr. Otis, and of Otis Elevator fame. That's still a viable company today. And about 160 years ago, 60 plus years now, he invented something called the Otis elevator safety brake. And so he went to the World's Fair, and he would stand inside of his elevator and cut the rope, the drop cable, and allow the elevator to start to fall, and his safety mechanism would come into play and keep the elevator carriage from going all the way down and hitting the ground. So he became pretty famous, and elevators then could now be used in some of the taller buildings that were being built at the time. And so that's what we have now, is more safety mechanisms implemented into elevators so that they're safe now. And so the same type of operation would of course take place for the development and improvement of lifters. So I took his safety device and put it here on my elevator, on my lifter. The drop cable goes down to the first stage of the output mechanisms, and it goes up through this pulley, a series of pulleys here, and is tied off down at the bottom of the carriage, the bottom of the lifter. And so this is sort of a reverse engineered Otis elevator safety brake. When this drop cable is pulled tight, then these lever arms pull the pinions away from the rack, and so that allows the carriage to go up and down. But using this method, you can see that when I pull these drop cables, that the pinions pull away from the rack, and the carriage is free to move up and down the vertical supports. So if anything happened to this drop cable, it would immediately cause the carriage to free fall. If the carriage should start to fall and it loses its tension, and you can see that carriage is stopped from falling because the pinions have been slammed back up against into their normal operating position for tilting, which is they engage the rack. This is the Otis-like safety brake. I'll show you, see if I can get a good view of this. There they are. There it is. It's free to move back and forth, and it's disengaged from the rack. These pulleys have pulled the levers together and disengaged away from the vertical support. There's another example of it slamming back into place. So it works really well. I'm really surprised at how well it does work without having to really make any kind of major modification to the lifter itself. This other safety mechanism that I've put in place is one that exists or is positioned on the axles of these shafts for each stage, output stage. I have one here. I've disengaged the pulleys going to this stage here, but you can see that as this turns, that large bolt rotates with the shaft, and the bolt slides out of the way under normal circumstances, so that as it rotates, it misses that large bolt here, which is the basically the brake. If this spins too fast, then it'll catch. And since there's not a lot of torque on this output here, everything from this second stage in the output is reduced, has reduced torque on it compared to the amount of torque that's on the large drums for the first stage. So it doesn't have to be too strong, but it has to be strong enough to stop the torque on this wheel here. I have another one here that works the same way. I'll load this up and put a short video on the back of this video showing you the output that you can get from 500 pounds on a lifter this size. Hey everybody, well, I've got the lifter carriage loaded, and I've got almost 500 pounds in there. I may have to top it off a little bit, but it's real close to 500 pounds. The first thing I wanted to show you was the magnet light. The magnet light is a bicycle light. It's produced over in Germany, and it's a really fine little light. It fits up on your bicycle, up to next to your front wheel, so that the rim will rotate past the base of this light. Whenever the rim of the bicycle wheel rotates past it, it causes the magnets inside here to turn, and that basically then operates the generator. The generator produces electricity then for the LED. So with this 500 pounds in the carriage, I can get a pretty good rotation on the little wheel that I've got over here, which simulates a bicycle wheel. It's got an aluminum rim on it, a plastic frame, so it's pretty light except for the aluminum that's around the outside of the wheel, and so it'll be enough to get this going. You can see my lifter here, I've extended the arms out. That's basically the only thing I had to do to make it as comfortable as it was to tilt when I had, say, 300 pounds in the carriage. So just by adding almost a foot more to the extended tilt arms, it takes almost the same amount of effort to tilt as it did whenever I had less weight in it. So that's pretty easy for 500 pounds. Only take a few minutes to tilt this up to the height that you need it to go. So I'll go ahead and release this, and we'll see it work. This is my automatic stop, or my hard stop. So I can put these anywhere I want to, and whenever the carriage reaches this point, of course it'll stop. So it's sort of like a timer, more or less. So if I know that my output is taking about an hour per foot, and that's how long I want it to work, is for about an hour, then I can put these those in there and stop it whenever I want to. So here we go. You can see my little wheel is really spinning. Let's see how fast it's going. Looks like about 590 RPM. So that's pretty good. Now I'll show you what happens whenever you put the little magnet light on there. You can hear it slowing down. Let's see what it's slowed down to. About 209, 208. Yep. So a little over half of the RPM is lost whenever the magnet light is put into place, which is what you would expect. It's pushing against the magnets inside here. So it's not a physical resistance from contact, but the magnetic field is causing a resistance on the driving wheel, and so that's enough to make a difference. everybody. I almost got an hour out of this. So you can see I've got this carriage loaded up quite a bit. So we're right at about 500 pounds. So with just a little bit of tweaking on the output pulleys, I think we could probably get an hour per foot. As it is, we got 45 minutes, so I feel pretty good with that. That would mean for 3 feet, 45 minutes, 3 times 45. Oh, what is that? That's a little bit over a couple of hours, so that's a good drop time. So we'll move on to the next example. Thank you. Hey everybody. Well, I've cleared off my work area here a little bit so I can show you some of these lights that I had whenever I was using the little generator that came out of the gravity light. And so I wanted to show you that this generator that I'm using now is able to put out voltage and some of its capabilities. I tried my best to get this little generator to produce electricity for these satellite lights for an hour with my 500 pounds loaded into the carriage, but I just couldn't quite make it. Only got about 45 minutes per foot, so that's pretty good. With another 100 pounds and a little bit of torque reduction adjustment to keep the generator going, I think I could have reached 1 hour. That gives you an idea of what 500 pounds in a lifter this size, the output that it can produce. And so far, we've shown that any kind of light source that requires about 3 AA batteries, this little generator can put out enough voltage to light those devices. These satellite lights right now are receiving about 2.6 volts, 2.7 volts from this generator, and they're not quite as steady as they are from this generator. I'm not real sure why. I think if I put a good capacitor, right size capacitor with the right capacitance, that I'll be able to get a better results. This one's too small. I do have the battery. This battery came out of one of these FR1 radios, and so one of my radios got wet and it wouldn't work any longer, so I scavenged all the parts, put the lights in here, took the generator and the gearbox out for future projects, and also the battery. So this was also a hand cranked radio. You've seen me operate it before with a lifter. So that's sort of a benchmark as to what you can do with a lifter of less than or equal to about 500 pounds. So let me show you this. This will also light up some of the other oddities that I have here. Let's see. Which one this one goes to? Yeah, this one goes to my little collection of lamps. There's 7 7 lamps with 6 LEDs on them. They came out of these little lanterns that I purchased for $1 a piece at the dollar store. So I bought 7 of them and took the guts out and put them all together. So this little gravity light generator will also light these, and like I said, it'll light anything that has a need of 3 AA batteries. This certainly lights up a lot brighter if it had a battery for each one, but that does a pretty good job. And it has an individual switch for each section, so you'll be able to string these across your garage, or like I have, or you can put them inside your cabin or your room, wherever you need them, or you could build yourself a nice fancy chandelier like I have. But they do put out quite a bit of light a piece. Collectively together they put up quite a bit of light. Let's see, another one I have that we used in the past was this little work light, and it's really bright whenever it's lit up. We'll give it a little push. We're getting about 2.6 volts, so that lights up. Let's see, I had one more. Let's see if this one. Now this is the light that came out of the FR1 radio. You can see it's not as bright as one that's got a good charge on the battery, but since this battery came out of the radio like that, once we get this charged up, we'd be able to get the same amount of output from it and use it for, you know, several hours. Let's see, what else have I got here? I have another generator that I had purchased. It's a military style. It's a little bit more expensive than this one. You can find these out on the internet. Just search for hand crank generators. Both of these came from China, and like I said, this one's cost twice as much as that one. But I don't see that much difference in the output, although this one does have a select box that comes with it, and it goes up to 28 volts. I don't think that one goes up to 12 volts. So, but for just low end use, it lights up pretty good. You can see these light up. So both of these are fairly good little generators. I haven't been able to do that much testing with them, but as time goes by and I increase the size or the output of this lifter, I'll be using generators more along this size than this size. So it'll require beefing this up a little bit and pushing it to to its limit and see how much of an improvement we can get over what we currently have. This one comes with all sorts of connectors for any type of device that you want to charge up or operate. This one has two USB connectors on the back and two sets of positive and negative posts for you to connect up cabling. It also has a switch in the back that gives you the ability to select like 3, 5, 6, 9, 12 volts on the back. So it's pretty versatile. Let's see, I have a couple of other type of output devices that I can hook up. One is this USB light. This light this is a 4-watt 8 LED lamp that you can hook up to let's see here, the USB port. There we go. That's not as bright as it can be. With a, let's see, this is a 4,000 milliamp per hour battery pack, so it's putting out the amount of power that this light needs to be really useful, I guess. And it is only marginal here at this drop rate for this particular operation. So you can see if I added more weight to the carriage and adjusted the torque and the RPM, that I'd get a much better output results. You can see that my emergency gravity, my throw out brake here works pretty much as expected. If I take the load off of the generator, and the generator will freewheel more or less. So if I take it off, it'll throw out the brake and hit this stop, and the generator of course will stop and the carriage will stop coming down. So this is one of the safety devices that was put into the lifter design this time. It'll also charge up this 4,000 milliamp battery pack. Let's see. You can see that it's charging. Charging lights are on. I realize this isn't real scientific. I don't give you any kind of I can't give you any kind of indication as to how long it would take to charge this up using this generator. So I do know that I'm not having to sit here and crank it to get it to charge. So if this was outside, or I had a roof that was a little bit higher up, I could tilt this up to more than 3 feet, and if it took 15 minutes a foot, then that's 45 minutes that for it to drop, and that's 45 minutes that I don't have to sit here and crank this. If I had 2 lifters this same size stuck together, so that they would turn this common output shaft here to this one generator, then that would be the same as having a 500-pound lifter 6 feet up in the air. So you can add lifters, or you can add weight to your lifter, or you can add height. All of that would make a big difference. So right now we're putting out 3.6 volts, and this is charging. And so I know this will charge. This little radio will charge up. And let's see. I've got one more device here that I think sort of tops it off. This takes it up to pretty much the limit of what I'm able to deal with right now. This is a 12-volt battery. And these are its little satellite lights. They're really bright, 12 volts. Can you see that? So again, I can't tell you how long it would take to get a full charge on that battery, how many times I'd have to tilt this up to drop it down, but the fact that it is charging is a plus. And let's see, we're getting 11. Oh. My brake. RPM on the generator is a little faster with at 12 volts than it is with some of these other devices, but I'm getting out about 11.7, 11.6 volts. So there we go. I hope that this was interesting for you. Certainly shows the different output devices that this generator or this generator can operate. Gives you some idea as to what this size of a lifter can provide for you. And with these safety measures that's being put in place, should be able to build bigger and better, safer lifters. Thanks a lot.